Hello everyone. In today's video we're going to talk about Nginx, worker processes, worker connections, and identifying bottlenecks with Nginx. So this is our agenda. We'll cover some of the key directives in Nginx related to worker process and connections, and followed by a quick demo. So we'll be using a Spring Boot application with Tomcat with Nginx as a reverse proxy. And then we'll look into the identifying bottlenecks with Nginx and identifying bottlenecks with Tomcat, right? So let's see how our setup is like for the demo and for this whole video, right? So you have this Nginx which is running on port 80. It is acting as a reverse proxy, which is for Tomcat, which is on port 8080. And all the clients are directly talking to Nginx, right? I mean, if you take your typical production application, so there might be a load balancer in front of it, in front of your Nginx. So the load balance and your Nginx and Tomcat, if you take them as two different containers, maybe they might be deployed on an ECS task or some EKS clusters or whatever your setup is, right? So the load balancer would keep sending requests to these ECS tasks, right? And then Nginx can be used to terminate your HTTPS, like the TLS termination can happen on Nginx and it would forward requests to Tomcat. But an Nginx can within itself act as a load balancer as well. But for the sake of this video and this demo, we are taking a simple application with Nginx as a reverse proxy. There is no HTTPS. It's a plain HTTP request on port 80. It forwards the request to Tomcat. It receives the request from the client, right? And then it sends back the response, if any. So this is how the setup is like for this demo, right? Now let's talk about how is Nginx, like the structure of the worker process and connections on a very high level, right? So you have this master process. It spins up to worker processes, and then each worker process internally handles multiple worker connections, right? And each worker connection internally handles these requests coming in from the clients. So I'll explain this again in detail after as we cover the directives, right? So now let's get into the directives. So the first one is the worker processes, right? So what does it say? It defines the number of worker processes, right? So the optimal value, it depends on many factors. Like this is the definition from the official Nginx documentation itself. I just copied it here. So it depends on many factors, including the number of CPU cores. For example, if your CPU has 8 cores, and then if you set this value to auto, but this is the default value, it would spin up, it would have 8 worker processes if you're running it on an 8-core machine. If your machine has like 16 cores, then the number of worker processes would be 16. So you can set it to auto. This is the optimal way to do it. You can also bump it up to a higher number depending on your testing, like the kind of traffic that you're dealing with, etc. Right? The second one is worker connections. So what is this? This sets the maximum number of simultaneous connections that can be opened by a worker process, right? So it should be kept in mind that this number includes all connections. So what this means is that, so as a client, once you are establishing a WebSocket connection, so this is from your client to Nginx, right? So client to Nginx, there is one connection, and then Nginx is establishing another connection with the Tomcat, right? So this directive here, worker connections, it includes both, right? Both the connections are they take account, like, so it is the maximum number of simultaneous connections that can be open, and the default is 512, and once again you can bump up or bump down this number depending on your requirements. The next directive is keep alive requests. So this is the maximum number of requests that can be served through one keep alive connection. So if you have one connection, and if you set this keep alive request to 10, that means that particular connection can serve a maximum of 10 requests. After that, the connection will not be kept alive. It cannot be reused anymore, right? A new connection has to be established. And the last one is the keep alive time. This limits the maximum time during which the request can be processed through one keep alive connection. So the default is 1 hour, but if you let's say set this to 5 minutes, that means if the connection is open for a maximum of 5 minutes, it will be closed, and then a new connection has to be established. So I will walk through all of these directives again as we look into the demo, and then as we look into the Nginx configuration, right? So this is a high level overview of some of the directives that we would cover, and this would how our sample application would look like, right? So now let's look into our sample application, right? The one that we'll be using for our demo. It's a very simple application. As you can see, we have Nginx on a Docker file. It's using the latest Nginx image, and then you have your Nginx configuration file here. So I'll walk you through all the directives that I just talked about. The first one is the worker processes. You have this set to auto, right? And then you have your worker connections. I set it to 100, but the default is I think 512, right? Yeah, I think the default is 512, but I set it to 100. Yeah, we can tune this number. And these are the last two directives that we talked about. First one is the keep alive requests, which I set to 2. It's a pretty low number. The default is 1000, but I set it to a low number just to explain you what it looks like. And the last one is the keep alive time. Again, the default is 1 hour. I set it to 10 seconds, right? And what you're really doing here is just added a log statement here which captures the process ID, the connection ID, and then some other strings like the remote address, remote user, request time, etc. Right? And then it is forwarding your request to this one called my test server, and then which is on port 8080. As you can see, it is proxy pass is set up here. So whenever it receives, it is listening on port 80, and then when it receives any particular request, it would forward it to this container here, which is called my test server on port 8080 by default, right? I'll tell you how these two things are wired up together. So this is your Nginx configuration. Now let's look into our Tomcat. So for the sake of this application, we are running a very simple Spring Boot application. It's just really bare bones. As you can see, just starting your application in here. And then in your test controller, you have this get hello endpoint. You're sleeping for 200 milliseconds. And then you're just logging here, just saying hello from server. And then you're logging the current thread ID, right? That's it. You're not even returning anything back to the client, right? So we're more interested in logs to see what is going on. And then if you see, this is the Docker file. This is again pretty simple. You have your OpenJDK setup, and then once you maven clean compile this package, this project, you would get this jar with your dependencies. So what you're doing is you're copying that to app.jar, and then you're just using this command, you're starting your Spring Boot application, right? Yeah, and then finally I have a simple script here, just a convenience script for me. So what you're doing is maven clean package, you're building your my test server. This is nothing but your Tomcat container. You're building your Tomcat container, and then you're also building your Nginx container here, and you have your Docker Compose file. So in here you're defining your Nginx server and then the test server. So if you refer back to your nginx.configuration, you're pointing to that my test server, right, which is nothing but your Tomcat application that you have defined here, which is running on port 8080, and your Nginx is on port 80, right? So far so good. So this is a simple setup, right? And what I'm using here for the sake of this demo is a simple Docker desktop where I have these two containers already up and running. So let's run this script, right? The script that I was talking about, this run.sh script that we have here. So clean package, again, build the two containers and then do a docker compose down, which takes down the containers and bring them back up again. So let's run it. All right, that's done. So if you go back here and just make sure they're running, see they're just up a couple of seconds back, right? Now let's try to hit this sample application and then see what it looks like, right? So let me refresh this. And then now let's go to the container logs and check what we have here. So as you can see, the first one is the process ID 31. This is the connection ID. And then the rest of the things are like details from the client, right? And here is your request time. It's like 285 milliseconds, right? So now let's do one thing. Let's send multiple requests here, right? 1, 2, 3, 4, 5. Then now let's check the logs. So as you can see here, these things keep changing, right? So this is your process ID, which keeps changing. Here it is 28, this is 30, and then this is your connection ID, which is changing as well, right? So now let's do a small tweak to the nginx.configuration, right? So what we want to do here is, let's set up the number of, instead of setting the number of worker processes to auto, let's set it to 1. So what we are saying here is, so I am running it on an 8-core machine, so there would be, if you set it to auto, that means it would spin up 8 worker processes, and each worker processes in turn would have 100 worker connections, right? That's the current setup, but now we are forcing it to just spin up a single worker process, right? Now let's do this run.sh again. It would copy this nginx file, build a new image, and then it'll bring up the containers. Now let's repeat the same test again. So in here I'll run this 1, 2, 3, 4, 5, 6, 7, right? I ran it 7 times. Now let's check the logs here. So as you can see, for the first 2 requests, the worker process ID is 29 and the worker connection is ID is 1. So it is the same if you notice for the first 2 requests. That means the same connection is being reused to serve the request from the client. But after that, as you can see, the worker process continues to be, the process ID is the same across all the requests. This is because we set the number of worker process to 1, but then the connection ID though is changing after 2 requests every time. This is because if you go back to our Nginx configuration, the keep alive request count is 2. So what this means is that a particular connection can serve a maximum of 2 requests. After that, a new connection has to be established. So that is why after serving 2 requests, a new connection is established, which you can identify this connection ID. Again, the worker process ID hasn't changed for all the 7 requests. This is because you set the worker process to 1, right? This is clear. And similarly, like if you send a single request and then after 10 seconds or like 15 seconds, like if you send another request, for example, see if the last request was sent with process ID 9 and process ID 29 and connection ID 9, right? So now let's send another request and see what happens. So I think we passed the 10 seconds. So let's run this and see. Hopefully it has changed. Okay, see, as you can see, even though it didn't serve 2 requests, but we went past the 10-second threshold, right? The one that we have defined it here, the keep alive time. So that is why a new connection is established, 29 and 30. So I hope the directives are clear to you, right? So the process ID, the connection ID, then a keep alive request, and also the keep alive time. So these are the 4 directives, and this is how you can look into your logs. Now we've covered the basics of the directives. Now let's run a simple load test using Jmeter, right? Before I run it, let me explain you what this is doing. Again, this is very simple. It is hitting localhost and our endpoint is hello, like whatever we hit from the browser here, localhost hello. And then if you check the thread group, what it is doing is it's spinning up 100 threads, 100 users. Ramp up period is 1 second, and then it is repeating this for like 10 times, right? So it means you'd be sending 1000 requests to Nginx. Now we have worker process set to 1, and now let's bring down this worker connections to 10, right? Just for the sake of putting Nginx under some stress, right? So we have 1 worker process, we have 10 connections, and now let's run this simple load test, right? So see the results here. Many of the requests are failing, right? So now let's see in the logs why they are failing. Like if you look into the Nginx logs, so you're seeing the number of worker connections are not enough. So in your production environment as well, even though you wouldn't really set it to a low number, you can still run into the same scenario where the number of worker connections that you have might not be enough. So it is always good to check in your logs and keep a close eye on your logs to monitor for these kind of exceptions, right? So now worker connections are not enough, right? So let's do one thing. Let's bump up the number of worker connections to 100. So now we still have 1 worker process. We have 100 worker connections. Now let's run the same test again. I mean, before we run the test, let's bring up the containers with this configuration. Alright, the containers are up. So let's clear this and then run it again. Right? See, you're still running into some errors here. If you look into this error, so it says it has failed to respond, right? Now if you look into the logs again, see, you're still running into the same issue. 100 worker connections are not enough, right? So now let's keep worker connections at 100, but let's tweak this thing called worker processes, right? So let's set this to auto and see what happens. So now you have auto. So like I said, I'm running on a 8-core system, so it would be like 8 worker processes should spin up, and each one can handle is spinning up 100 worker connections, and each connection can in turn handle several requests, right? So it is not like there would be 1 connection for 1 request. Like every connection can simultaneously handle multiple requests. That is the beauty of Nginx, right? Because it uses IO multiplexing. So for the performance, right? So I think that is why it's really fast. So if you might have heard about event loop when you're dealing with Redis and also with Node.js, right? I think it is very similar for Nginx as well. So it uses IO multiplexing with event loop to achieve this high performance, right? So now let's run our test again. So if you run this test, so now let's check the summary report. So you can see all 1000 requests have passed, right? So 0 errors. And then you can see the average is like 200 milliseconds, maximum is close to 300 milliseconds. So now if you check your logs, pretty clean, right? So there are no exceptions at all. Now all of them are 200s. So now this is how you can identify some of your bottlenecks with Nginx, right? So maybe there is an issue with like your worker process, or maybe there's an issue with your worker connections, or you can tweak some of the other settings like your keep alive requests and keep alive time, right? There are a few other things as well to keep in your mind, like the number of file descriptors. I think that also can go wrong, but I'm not going to get into the details of it. I'll probably come up with another video explaining in detail about some of the other key directives which you need to look into as well for the Nginx performance tuning, right? So now let's in our final section, let's see what happens if tomcat is the bottleneck, right? So in case of tomcat, as you can see, tomcat, you can set the maximum number of tomcat threads using this property, right? So tomcat threads max to 100, right? I think the default is 200 if I remember it correctly, but I have set it to 100. So now let's bring it down to 10 and see what happens, right? So let me run the same thing again. So it is using this new application YAML, max thread set to 10. So tomcat can only take maximum of 10 threads. Now let's repeat the same test again. As you see, it's taking some time to finish or run through all the 1000 requests, right? The last one was pretty fast, and we've seen that it was taking around 200 to 300 milliseconds, right? Now let's see how it is doing here. Alright, as you can see, there are no failures, which is good, but the average request went from 200 milliseconds up to a maximum of close to 2 seconds, right? It is 1800 milliseconds, and the max went up over 2 seconds, right? This is 2000 milliseconds. And then if you're curious, you can look into Nginx logs as well to see some of the other things, like see the request time here which we are logging. It is taking 1.4 seconds. This is because your Nginx is able to take all the load, but it is waiting for tomcat to accept that request and actually process that request. Since you set the max threads to 10, as more number of requests are being sent to tomcat, they're waiting, right? They're waiting for a free thread from tomcat to pick it up and to actually process your request. So whenever in your production, if you notice that your CPU is pretty good, your memory is good, everything looks great, but in spite of all of it, if your latency is still shooting up, so I think you can look into these configurations, like look at your Nginx configuration, look at your tomcat configuration, and see and identify which one is the bottleneck, right? In one of my previous videos as well, I think I've talked about load shedding in tomcat, right? Like so I'll put a link in the description for that video. Take a look at it if that is something that interests you. Yeah, so that's pretty much that I wanted to cover in this video. Thank you so much for listening to this, and please let me know if you like it. If you don't like it, I always love to get some feedback, and also let me know if there are any other topics that interests you. I'll try my best to come up with a video. Yeah. All right. Yeah. Thank you, everyone. I hope you enjoyed the video. Please do share and subscribe. Thanks.